Very good morning to all of you. I am CMA.Dr.Jeelan Basha V, Professor, Department of Studies in Commerce, Vijayanagara Sri Krishnadevaraya University, Ballari. Now, I have been instructed my students and my teachers to deliver a lecture on exploring practical applications of linear and non-linear models in business research. Now, this is more about mathematical applications which we need to apply it in our business research. This is a very interesting topic, provided the commerce student should have known the basic mathematics. Let us try our best to understand how the mathematical application can be used in business research methods. Now, let us go to my objective of presentation. What is my purpose behind my presentation? The purpose is how to develop, how to evaluate, how to compare linear and non-linear models in business research. This is my objective. Now, many of commerce students may not know they may know it, how to develop a linear model, but not non-linear models. That I'll try my best to make you to understand. Here, a commerce student's presentation for non-linear model is quite different from a mathematical student. So that I'll try my best to understand my students how far they can understand. Let us come to first, what is model? Model is nothing but a simplified representation of a reality which is used for explaining, which is used for predicting, which is used for understanding a phenomena. This is called model. We explain in general sense. Let me repeat once again. Model is a simplified representation of a reality which is used to explain, which is used to understand, which is used to predict the phenomena. Phenomena means it is an observable event or occurrence. Now, this model can be explained in different contexts, in different angles. As I am presenting on linear and non-linear model, let me say what is a model from the point of view of mathematics and statistics. When it comes to statistics point of view, model is representing the relationship between the variables. It represents the relationship between two or more than two variables. Here one variable is a dependent variable, another variable is a independent variable. We want to know the relationship between the dependent and independent variable. That we are going to take it forward for my further presentation. Now, the same model we explain in our business. Model is nothing but a company creates or delivers a models to capture the value. It develops something to create a value, to deliver a value, to capture a model, to capture a value. This is called a model in a business sense, or in a usual business people will speak it. Now, let us come to, once the model is over, let us come to the types of model. Before that, we'll go to what is the purpose of model. Model is used for testing the hypothesis. Model is used for predicting the observations. Model is used for supporting decision making. Model is also used for guiding the collection of data. Model is also used to illustrate the theories. These are the purposes behind usage of model. But here, from our point of view, here model we are using for the purpose of testing hypothesis. Model is also used for the purpose of supporting our decision making. Model is also used for prediction. Let us come to there are various types of models we have. Like models from the point of view of theory, theoretical model, statistical model, conceptual model, again simultaneous model, again empirical models. Here we categorize the model from the point of view of the relationship between the variables. Though there are many types of models from different contexts, but we are taking the model which we can classify the observation into two categories based on the relationship, that is called dependent and independent variable. Based on relationship between variables using dependent and independent variables, there are two types of models. One is a linear model, another one is a non-linear model. What is linear model? The linear model is one in which the parameters in the linear are constant and additive. It has always a straight line relationship. It has always a straight line. When the entire data is presented on a graph, it will be visualized as a straight line. The effect of independent variable, it is going to study the effect of independent variable on the dependent variable. That is called linear model. It has always a straight line relationship. Or in other way we can say, the proportionate change in a dependent variable due to change in independent variable. That is called linear model. We take a practical examples of linear model. Profit depends on expenses. There is a proportionate change in profit due to change in the expenses. If the expenses are increased, there may be a positive relation, there may be negative relation. Not necessarily that there should always be a positive. But the thing is here, a constant change will be there. That is called proportionate change is very important. With the increase in expenses, there is a proportionate decrease in profit. With the decrease in expenses, there is a proportionate increase in profit. So the profit depends on expenses. Another example also we can take. Salary depends on experience. With the increase in experience, there is an increase in salary. There is a proportionate. With the 1 year experience, you will be paid, for example, with the 1 year experience, you will be paid 10,000 rupees. With the 2 years experience, you will be paid 20,000 rupees. With the 3 years experience, you will be paid 30,000 rupees. This is what we can call as a proportionate change. Even it can also be used in many areas, not only in finance, in accounting, even in logistics also we can use it, this one. With the increase in distance, there is a increase in delivery cost. The delivery cost as well as distance has a linear relationship. This is called linear model. This is a real-time examples we come across in our day-to-day life. But in order to adopt this linear model, there are some assumptions we need to assume it. First assumption is linearity. Our model is linearity. It means that our model, when it is presented on a graph, either through scatter plot or through residual plots, partial residual plots, or through your calculation, mathematical calculation. This linearity can be tested either by visualization or by mathematical equation. If it is visualized, there we see a scatter plot or partial residual plot, we see it. There should be we come across there is a straight line. When it is a straight line, we come to a conclusion that it is a linearity. If you are not sure with the visualization, you can go for mathematical calculation. There are n number of mathematical equations are there. Equations are there for testing the linearity. Very popular is, we can call it a Ramsey test. We can call it a reset. Ramsey reset test, we use it in order to determine whether your data is a linear or non-linear. This is the first assumption of your linear model. Second one is, your data must be independent. Your data must be independent. Whatever the variables you are considering for your calculation or estimation should be independent to each other. they should not be dependent on one another. Whatever the data variables you are collecting at random. They are not collected at a particular point of time where there is a cluster or group. You are taking randomly from one group, one variable, one observation, another group, another observation. Like that you are taking independently each observation. When you take it, the observation or variables independently, they are not dependent on each other. This is a must. If they are dependent, there is a problem of collinearity. That I will say you later. What is that? So that your data must be independent. Second assumption. Third assumption, your data must be homoscedasticity. What is homo means same, scedasticity means variance. There must be equal variance of your data. What is equal variance? Whatever the data you take, when you calculate variance, there must be same variance. No, if not same, at least at 5% of level of significance, there must be same. Whether if you take a 10 observation, if you want to calculate variance, if out of 10 observation, if your variance comes 5, example, even if you take half of the observation, if you calculate variance, there must also be 5. Even if you take 1/4 of the data for the calculation of variance, there will also be the answer is 5. So at every level, at every broken fragmented data, you will get the same variance. That is called homoscedasticity. This can be visualized. This can also be calculated with a mathematical calculation. Now, if you want to look at this, what type of data, if you look at visualization, we look at QQ plot, we'll see. Normal QQ plot will decide whether your data is homoscedasticity or not. Otherwise, you can go for mathematical calculation like Bruish-Pagan test. BP test, we can use it in order to determine whether your data is a homoscedasticity or not. This is the third assumption. One more fourth assumption we have, that is called normality. Whether your data is normally distributed or not. What is normality? We say very simple. Normality you get when the mean, median and mode of the data is same. When you calculate the mean of the data, the median of the data and mode of the data almost same. If the mean, median, mode are same for that data, we say that data is normally distributed. This can also be tested by visualization as well as by mathematical calculations. If you want to use it visualization, we can use an histogram. Histogram is one of the methods of visualization to determine the normality. This it will have a bell-shaped curve. When you plot it on a graph, it will find a bell-shaped curve. Your frequency curve will be bell-shaped curve should be there. When bell-shaped curve is divided into two parts, half of the left side should always be equal to the right side, half of the right side, that of right side. That is called normality. Now, this can also be tested by mathematical calculation. There are n number of tests we have. The popular is, we can call it as a Shapiro test, or we can also go it for many tests we have, like Jarko-Bera test is also there. We use it either Shapiro test or Jarko-Bera test to determine whether your data is normally distributed or not. Now, next one is autocorrelation. Now, here autocorrelation means your current observation has any kind of correlation with its own previous observations. Your current observation has any relation with its own previous observation, for which we calculate autocorrelation. We should see that the data must be free from autocorrelation. There must not be autocorrelation. This can be calculated with the help of mathematical calculations. mathematical test that we can call it as a Durbin-Watson test. Durbin-Watson test. This can also be tested through Bruish-Godfrey test. Also we use it in order to determine whether your data is autocorrelated or not. Now with respect to setting of hypothesis for those tests, I will tell you in my next presentation is the next slides. Otherwise here only we can say. Now in order to test it whether your data is a linear or non-linear, your null hypothesis is linear, your alternative hypothesis is non-linear. In order to test your homoscedasticity, your null hypothesis is a homoscedasticity, your alternative hypothesis is heteroscedasticity. In case of normality test, your null hypothesis and your data is a normally distributed, your alternative hypothesis is not normally distributed. In case of autocorrelation, your HO is not, that is called null hypothesis, there is no autocorrelation. Alternative hypothesis, there is autocorrelation. So that these are all hypotheses we need to set when we adopt a mathematical equation. Example, let me repeat once again, one small example, linearity. What we set the hypothesis is, there is a linearity, HO is there is a linearity, H1 is there is no linearity. If we calculate Ramsey reset test, your p-value, this is a p-value is going to determine whether null hypothesis is accepted or alternative hypothesis is accepted. To accept null hypothesis, your p-value should be more than 5% level of significance. We are testing the hypothesis at 5% level of significance. It is nothing but 95% confidence level we are testing the hypothesis. It is a universally accepting or rejecting at 5% level of significance. Even you can test it for much more accuracy, for more significance, you can go even for 1% level of significance also you can test. But by default almost all of them will accept at 5% level of significance. HY is there is a linearity, H1 is there is no linearity. In order to accept the null hypothesis, your p-value must be more than 5% level of significance. That is called your p-value must be more than 0.05. In case alternative hypothesis to be accepted, your p-value must be less than 0.05. In case your p-value is less than 0.05, we can say that there is no linearity. Like that we have to set the hypothesis for each of the mathematical tests, or for each test we need to set what is HO, what is H1. Like that for homoscedasticity, like that for normality, even for autocorrelation. Now let us come to what is a mathematical equation for this linear model. We say very simple. Y is equal to A plus Bx plus error term E. Y is a dependent variable. Here dependent variable from our example, what has been shown on the slide. Like profit is a dependent variable. Y we can take it as a dependent variable. A is we can call it as a alpha, or we can also call it as a intercept. What is intercept? What is alpha? This is a contribution to the dependent variable when the contribution of all the slopes are 0. This can be explained very easily. The dependent variable is influenced by 3 things. One is internal, second one is external, third one is unexpected. One is internal events, external and unexpected events. Internal we can call it as a alpha, that is called intercept. What is the contribution is emerging out of your internal source, that is called A, alpha. Next one is beta, that is also we can call it as a slope. Now what is the contribution of x to y? What is the contribution of x variable to y variable? That is nothing but that is explained with the help of coefficients. Alpha, beta, error term, these are all we can call it as a coefficient. Now this is what external, how much x is contributing as a outside variable to y variable, which is explained with the help of b. The third one is unexpected, error term. This is unexpected contribution to y variable. This we cannot predict it, hence we assume that it is a 0. So this external variables may be more than one. Here we have taken only bx1. If there are more than one external variables are there, b2x2, b3x3 plus, we go on adding. bx1, b1 x1 plus b1, b2 x2 plus b3 x3 plus b4 x4, b5 x5, like that. This will be continued here. This will be continued. This go on increasing this further like that. Plus like that. This is called linear equation in the mathematics. I hope you got it. What is linear model? It is very simple way. I can say further, repeat it. It is a straight line relationship. There is a additive model. Why it is additive model? In the equation there is a plus signs are there. A plus b1 x1 plus b2 x2 plus b3 x3 plus. There are no product. There are no any other mathematical signs like square, like log function, like exponential function, like power function. There is no such functions in the equation. If such functions are appeared before coefficients, then we can say that that is called non-linear model. So non-linear model is one where the relationship between dependent and independent variable is straight and constant. Again, the residuals of these variables may not have any pattern. They are all random. One more characteristics we find from the linear model is that the residuals. What is the residuals? The difference between expected and actual. The difference between actual minus predicted or expected, that we can call as a residuals. The residuals of this data must be random. When these characteristics are found, we can say that linear model. Or this can also be directly we can calculate with the help of, that is what Ramsey reset test that will tell you. Even there are many like Harvey-Collier test is also there for non-linear calculation. There are many are there. I am giving one or two so that you should not get much confusion by saying many tests of same category. Now this is what I say what is linear model. Now question comes, when to use linear model. This is very important. When the relationship among the variables, that is called between dependent and independent variables, are very clear, they are very simple and they are straight line. When the relationship among the variables are clear, simple and straight line, we use linear model. That is what proportionate change in dependent variable due to change in independent variable. If you look at characteristic of linear model, it is easy to interpret and estimate. The reason is that there is a additive model. There are no any mathematical signs which are very complex to understand. Sometimes power cubed, power of 4, raised to the power of 5, or exponential sign, or some other log function, many other functions, square, like that. Many functions are there. We as a non-mathematics students, we cannot much understand. It becomes more complex. So linear model is very easy to interpret and estimate. It is a faster computation. Calculation is also very faster in comparison with your non-linear model. It is a very rigid model. You cannot change anything. It will not have much flexibility in its calculation. Again, it is a OLS estimation, ordinary least square estimation. Now this all, when to use this linear model? Now application of linear models in business. I have taken few real-time examples that we know it, many of us. In case of marketing, predicting sales from advertisement spending. This can be used for linear model. You can predict sales from your advertisement you are spending over a period of time. Sales you can take it for a period of 10 years, advertisement you spent, take it for 10 years, you can predict for the 11th year. Coming 11th year and 12th year you can predict it. These sales and advertisements have linear relationship. In finance we can take a CAPM model, that we can say capital asset pricing model. This is what a single factor model. Market risk is considered in order to measure the return of a security. So here returns of a security is influenced by market risk. Higher the market risk, higher the returns. So market risk is a independent variable which is influencing the returns. So CAPM model is also a linear model, capital asset pricing model. There are now many factors model has come, like 3-factor model, 4-factor, 5-factor, 6-factor form of range models are there, but we don't want to explain. CAPM is a single factor model, is very easy to understand. Even in operations also we can use it. Cost minimization from usage of inputs. This also we can use it as a linear model. HR also we can use it. Predicting salary from the experience of employees. The salary of 10 years you can take it, how the salary has been changed over a period of 10 years, and his experience you can take it. Salary is a Y variable, experience is a X variable, you can take it, you can calculate a linear model, regression. Simple regression you can calculate, you can predict. With the help of that you can also predict what may be the salary with the further increase in experience. These are all practical real-time example we come across in our linear model. Let us come to the linear pattern. This may be a pattern when it is plotted on a graph, your data, there will be a straight line. If there is a curve, then it is called nonlinear. If you find curve, see the straight line, then we immediately say that this will have non-linear pattern. So this is a visualization of linear pattern. Let us come to the non-linear model. What is non-linear model? I told you. The change in a dependent variable may not be proportionate to the change in independent variable. They may not be proportionately changed. There may be disproportionate change in dependent variable due to change in independent variable. Here the relationship is not constant. The relationship is not of additive. The relationship may be of log function, may be of polynomial function, may be of exponential function, may be of logistic function. The relationship may be of different category. It is what we can call, it is a curved type of relationship. When you plot the data on a graph, you may not have straight line what it was shown previously. You will have curves. The non-linear models are of two various categories that I am explaining. Very simple. Functional form of linearity, non-linearity, time series models of non-linearity, machine learning models of non-linearity. There are three categories of non-linear models we have. First one is very simple, second one is much more complex, then third one is the most complex. The simple way we say that functional form of linearity, we use exponential signs, we use it, e value 2.7183, exponential we use it before your independent variable, rather than using like plus or multiplication which will be there, that we use it. Exponential form of function. Logarithmic form of function, natural log, we use it here. Polynomial function is a hyperbolic function. It is where we use it powers, power of 1, power of 2. With the increase in independent variable, the power will also be increased or changed. Power log function, logistic function, cyclical function, more fluctuating function. These are all one category of non-linear models. Second category of non-linear models are time series model, that we can call it the arch and gorge model, auto-regressive conditional heteroscedasticity, gorge model. There is a family of arch is there, arch, gorge, T-gorge, U-gorge. There are many are there. I am not going to explain much here. That's not our topic to discuss. These all arch and gorge models are time series models of non-linearity. And one more TAR model, threshold auto-regressive model. Here the regime shift will be there. The threshold means a particular limit is fixed. Before that, how the regime, before that how it was, after that regime change, threshold changes comes. When threshold is changed, when limit is changed, what may be the change? That is what TAR model, we use it. Again, one more STAR model is also there. Smooth threshold auto-regressive model. Again, MSM model also we use it, that is called Markov switching models. These are all categories of time series models. The third is a much more complex models, that is called machine learning models. Why it is called machine learning? It is very difficult to calculate manually. We use softwares like we use Python, we use R, we use MATLAB, we use eViews, we use SAS. There are different softwares which are available for calculating machine learning models. We use it because it's all iterative model. Your answer will not be arrived at a single shot. You need to calculate again. Often there may be one where there is a optimization. You need to calculate trial and error method till you get your optimum model, till you get the best model. In case of machine learning model, there are few categories we have taken for my presentation, like one is neural network. Next one is random forest, decision tree models, gradient G boosting models, support vector regression models. They are all very complex models. Sometimes it is beyond our knowledge, sometimes you feel, but if you develop it, it is not so tough. We can also do it. We can also write an article using this machine learning models. Now, I told you what is non-linear, what are the categories there, when to use the non-linear model. I told you, when it comes to linear, when it is easy, simple and straight relationship is there, we use linear. When the opposite comes, when the relationship among the variables are very complex or threshold limits exist, then we use, when your answer may not be arrived at single calculations, we need to do it many calculation till we get optimization model. When that is there, we always go for non-linear model. You cannot get your answer at a single shot. This is what we can call as a non-linear model. When the relationship among the between, that is what dependent and independent variable is not straight line, it is a curved relationship. I will show the graphs of those, then you will understand what it is. And there is not constant change, there is a varied change in the input, that is called dependent variable, due to change in the independent variable. Now look at the characteristics of this non-linear model. We say that it is the most difficult to estimate. It requires iteration again and again, trial and error till you get a optimum model. We use it in especially in finance, like IRR, internal rate of return, we use it. We have to find out that rate at which present value of cash inflows is equal to present values of cash outflows. We never get exactly, we cannot imagine also this may be the exact answer for that IRR rate. We go on doing it till we get. There are some hints are there, there are some clues are there which we adapt it in order to arrive at that right rate of return. These are all machine learning models are there, many are there, that I will explain you that later practically how it can be done. This requires, computation requires, I told you, optimization algorithm. It is very flexible, you can change the variables. If you don't get, you can change power, raise to the power of 2 to raise to the power of 6. If it is not obtained, you can go for exponential form, you can go for logarithmic form. Like that, there is a transformation of functions, mathematical function can be used. Transformation can be made, but linear we cannot make. That's why that linear model is not flexible, but this is a flexible but most powerful model. It is the best for classification as well as volatility. So these are the characteristics of non-linear model. Now non-linear pattern, the pattern may not be straight line, it may be it is a curve. The curves are of different types. It is a U-shaped curve, it is a S-shaped curve. Are you getting me? There are V curve, there are many curves are there. That based on that curve pattern, we can say what type of model it is. What type of model it is also we can decide. So when you present your data on a graph, when you don't find straight line, you say that it is a non-linear. It is a curved one, so that here we say that many functional. These are all types of non-linear pattern. Exponential. This exponential pattern is also there. When there is a rapid change, increase or decrease is there in your data, then we can call it as a exponential. Exponential growth or exponential decay. If there is increase is there, we can say that exponential growth. If there is a decrease is there, we can say exponential decay. When there is a rapid change or whether rapid increase or decrease we come from any data, we say that it is an exponential pattern. This will have always a J-shaped curve. This always have J-shaped curve. The examples of this are population growth is an exponential growth pattern. Again, viral marketing spread is also an example of exponential pattern. Now, equation, when you look at it, mathematical equation, y is always dependent variable, x is always independent variable. Y is equal to alpha into exponential power of bx. Here exponential mathematical function is used instead of using the plus simple without using, but is a power is there. So is something complex now. Earlier very easy, because in linear model there is no any such complex things, only plus will be there, additive. So it was easy for us to do it. But this is something complex, it has come. Some new mathematical sign has been appeared before your coefficient of independent variable, then it becomes some complexity has come. So this is what we can call as a exponential pattern and exponential mathematical equation. Next one is logarithmic pattern, logarithmic function of non-linear model. Here, how the data of this category means there is a rapid increase, thereafter it levels off. It will first fastly it will increase, then it will be stabilized. Rapid changes at first, then levels off. This shape we can call it a concave curve. Now this you can find it on the slide also. This is what all concave curve is there. This is what concave curve. This is what concave curve, we have a shape of concave curve. This is a shape of concave curve. This is what concave curve, this is what concave curve. This is what the concave curve we use it when it is a logarithmic function. The equation is y is equal to a plus b into log x. The log is used as a new mathematical sign for non-linear model. This is applied in case of practical application is in case of learning curves we use it, in case of calculation of diminishing return, constant return and increasing return we use it. So this is what third one again will go to. Now this is practically applied in case of learning curves as well as diminishing returns which we use in economics. So this is what we have one. Then next we have third one, power law distribution. This is another pattern of non-linear model. Here small values are more and larger values are few. When that is there, we use this model. This shape is, we can call it as a straight on log plot we can call. The shape of this is, it is a straight, just like a straight it will be found the way you are finding here. It will be just like a linear we find it. If it comes exactly straight is a linear, but slightly it is a curve is there. When slight curve is there, we can call it as a log plot curve, straight on log plot curve. It is used practically in case of wealth distribution and in case of city sizes where this can be used. The mathematical equation of this is y is equal to a into x to the power of b. Here there is no additive model, it is a product model. The multiplication is there. Again b has become a power of x. Is it? Now power of x has come, so that this is what another pattern we come across. The next is fourth pattern of non-linear model. This is called quadratic or polynomial pattern. It is nothing but parabolic shape or curvilinear shape. This is what shape as you come across in our graph. Either it may be downward or it may be upward also. Not necessarily that it is always downward. U-shaped curve we say pattern or inverted U-shape. Inverted U-shaped curve. This is practically used in case of estimating cost curves or in analyzing performance versus stress we use it, this quadratic pattern of quadratic pattern of non-linear model. The mathematical equation is y is equal to a plus b x plus c x to the power of 2, x to the power of 2. This is what equation, mathematical equation we use it for quadratic non-linear pattern. This is another pattern we have. The fifth pattern is sigmoidal pattern or S-shaped pattern of non-linear model. It is also called it as logistic curve. Here this is a S-shaped curve. Slow will be there, again fast will be there, again slow will be there. It will be upward or it may also be downward, but slowly it will rise, thereafter fast it will rise, then slow it will rise. Slow, fast, slow, increase. This is S curve. This is more used in case of product adoption. In case of population saturation, this model is extensively used. Now this is another pattern we have. The last pattern is mathematical function which we use it for non-linear model is cyclical or periodic pattern. Cyclical or periodic pattern. This is used when there is a fluctuations, ups and downs when you come across in any data, that is called wave-like fluctuations. When we come across, we use this cyclical or periodic pattern. The shape is wave-like pattern, or it is also we can call it as a sinusoidal pattern, soidal pattern. The example we use it in case of estimation of business cycles and seasonal trends we use it. Y is equal to A plus sin sine into bx plus c. This is a mathematical equation we use it for this cyclical pattern of non-linear. Logistic models we use more for the customer retention. In order to study the customer retention, whether the customer retention, we go for this logistic model. Even for pricing strategy we use it polynomial model. In case of finance, for Garch calculation of for the estimation of Garch models, that is used for volatility forecasting. How fluctuation how there is a variation in a data that can be forecasted with the help of Garch model. This is used in finance. Even risk models for which we also use this non-linear models in finance. In consumer behavior, in a subject of consumer behavior we use neural network. In supply chain management we use power law models. For demand prediction, for neural network for logistic optimization we use it. In econometrics we use it threshold models for economic cycle, that is called up to a threshold limit there is a one chain, after that beyond that there is another chain, that is called, we can call it as a regime change, regime shift we can call it. These are all we use it in case of non-linear models. Now let us come to now practical example we use it for non-linear models. This is how we can use those models in practical, in research. I have taken my own example that is called, I want to find out or know what are the determinants of dividend policy. This is what my topic I have taken for study it. Now I took the data for this estimation. The data is for a period of 2000 to 2024. Around 15 years annual data I have taken. The company I have taken 23 companies. These are all BSE Sensex company I have taken. Out of that 7 companies they are related to finance and banking that I have eliminated because of some non-availability of some variables for which those have been forced to be removed from my 30 companies. I have taken only 23 companies data. The variables I have chosen 13 variables for the estimation of determinants of dividend policy. In these 13 variables, now DPS, dividend per share. Dividend per share is a dependent variable which is also called it as a response variable. Others are independent variable. Out of 13 variables, one is a dependent variable which is known as a DPS. The others 12 are independent variables. They are also called it as predictors. They are earning per share, return on net worth, return on total assets, quick ratio, debt to equity, debtor turnover ratio, creditors turnover ratio, price to earning ratio, PE ratio, price to book ratio, PB ratio, yield ratio, assets turnover ratio and size. Size is decided based on the total assets, amount of total asset. So the data is collected from the CMA data, Center for Monitoring Indian Economy, that is called PROVESP we have taken. This is the data we have taken in order to estimate the determinants of dividend policy. Now, when we have taken all the 12 variables as an independent variable, all 12 variables are not suitable for considering them for estimation. Before that, I have to check whether there is any problem of collinearity, multi-collinearity among these 12 independent variables. If there is a strong correlation, whether it is a positive or negative, among this independent variable, there is a problem of multi-collinearity. If there is a strong relationship is found among the variables, it is very difficult to say what is the contribution of those variables to the dependent variable. So, in order to know clarity, in order to know genuine results, we need to avoid the problem of collinearity. The problem of collinearity is calculated with the help of VIF, variance inflation factor. Variance inflation factor is going to decide whether your independent variable has multi-collinearity or not. One more test is also there, that is called tolerance test, is also used for this multi-collinearity. Now, once we get the VAF, we divide the VAF into 3 categories. Less than 5 is a low collinearity, 5 to 10 is a moderate collinearity, above 10 is a high collinearity. We see that our independent variable may not have high collinearity and moderate collinearity. They may have low collinearity. In order to have low collinearity, our independent variables VAF should be less than 5. So, when I have taken those 12 variables for calculation of VAF, we found only 5 variables whose VAF is less than 5. EPS has a 2.74, it is a low collinearity. Quick ratio has a 2.91, it is also low collinearity. Debt equity ratio 1.84, creditor turnover ratio 3.82, and size is 4.99. With this, I came to conclusion that these independent 5 are suitable for the estimation of determinants of dividend policy. So, I have finally taken those 5 variables as an independent variable for calculation. This is a visualization of those 5 variables using VAF as a base for data graph presentation. This is what almost all of them are less than 5 is there. So, that we have gone for this. Now, I have taken one linear model, 4 non-linear models for the estimation of determinants of dividend policy. I have taken totally 5 models for the estimation of determinants of dividend policy. Out of 5, one is a linear model, other 4 are non-linear models. First one is a linear model. That linear model I have taken mathematical equation to know it, because when we are using some mathematical equation, we need to know how that can be presented in our research articles. That is called DPS is a Y variable, that is called a dividend per share I have taken. DPS is equal to BO is nothing but here is a alpha, that is called intercept, plus B1 is a coefficient of first independent variable EPS. Coefficient of first EPS is B1, that is called beta 1, that is also called it as slope 1. Beta 2 of QR, quick ratio, that is a second coefficient, second beta of QR. Now B3 of D, B4 of CTR, B5 of size plus error term. What this beta say? Now, a 1 unit change in EPS, independent variable, what may be the change in dependent variable? That is explained by beta. Let me repeat once again. The coefficient beta 1 says that what may be the change in dependent variable due to change in 1 unit of EPS. Similarly for other independent variable, like B2 will say what may be the change in dependent variable, that is called DPS, due to 1 unit of change in quick ratio. There may be a positive relation, there may be negative relation, need not worry what sign it is. There may be negative relation may also be there. Like example I am saying. A 1 unit decrease in QR, quick ratio, there is a increase in dependent variable, that is called DPS. Here decrease in quick ratio, there is a increase in DPS. They may also be there. Not necessary that all independent variable have positive relation with the dependent variable. There may be 1 or 2 negative, may be there. You should not worry about negative signs. That relation may come. So second is a non-linear model we are taking, that is called log transformation model. Here B0, that is called intercept, B1 is a coefficient of log, here we have used, be clear. We have not used a log for all the variables, we can use it log for some of the independent variables. It is you to decide. Because if you want, you can use it all independent variable in log function also you can use it. Log of EPS we have used for first independent variable. For second quick ratio we have not used any log function. But for date equity also we have not used a log function. When it comes to log of size we have used. Only for two independent variable we have transformed the plain function into log function. Now similarly log, wherever log is used, that we can call it a log transform model, which comes under one of the categories of non-linear model. Third model is polynomial model. It is a hyperbolic model. Here your power goes on increasing. In first independent variable power of 1, second independent variable power of 2, like that. There may be change in power with the increase in your subsequent independent variables. Again here also it doesn't require that powers can be used for all the independent variable. You can decide it. Unless you get till you get your model is good fit. Till your model is good fit. Because I have used a polynomial function only for EPS. That is 2. EPS comma 2 means power of 2. The same I have not used for other independent variables. They are all plain. B2 is a coefficient of QR. B3 is a coefficient of D. B4 is a coefficient of CTR. B5 is a coefficient of size. Here I have used a polynomial function only for the EPS independent variable. So whenever we use any mathematical function either for one or for all, this becomes a non-linear function. Not necessary that you should use it mathematical functions for all the variables which you have considered. Second one is GAM model. This is a general additive model. Here smoothing parameter is used as a lambda that is going to be adjusted by its own till it gets maximum, till it gets optimum. But what is that parameter, how much it is, that smoothing parameter, that I have not known. Because I have used R program for my estimation, that itself will adjust it by using iteration method. Then what may be the smoothing parameter each it is taking for each independent variable. Now DPS is equal to A plus. Now this is what DPS is equal to A plus. A is a intercept. Then here smoothing parameter has come. Now what is that value? I don't know, because it may be automatically adjusted to as a coefficient to the EPS in such a way that it has to give optimum number. Like that, smoothing parameter for QR, smoothing parameter for DE, smoothing parameter for CTR, smoothing parameter for again size. This is what we can call as a generalized additive model. This is another category of non-linear model. The last non-linear model is a non-linear model. Non-linear model. Least, actually that is full form is non-linear least square model, NLS. Here also we use it sometimes exponential. Here exponential we have used in this. Not necessary that exponential to be used for all the independent variables. It is you to decide. Sometimes what we do, we go on applying E to one by one for each independent variable till we get optimum. First we apply to one, we will see what may be our measure of value as a good fit. We look at it, whether this model is good fit for with that one exponent. With the second exponent we see again our good fit measure is satisfied or not, that we will see it. Whether our model becomes good fit or not. So like that we are going to do it. This is how it is. Now this mathematical equation, when it is replaced with the real values, with our data, to our data, this has come. Now for linear model, DPS is equal to 17.91. It is a intercept, that is called alpha, plus 0.1008. It is a coefficient of EPS, beta 1. Then there is a plus sign. When it comes to QR, there is a negative relation, be clear. There is a negative coefficient. minus 0.4976 coefficient of quick ratio. Again for D also there is a negative relation with its dependent variable of DPS D. Even CTR also negative relationship. See here, CTR also negative relationship. Size is a positive, no doubt. Let me say what it says. Now first one is 17.91, it is contributing to it is a baseline. It is a contributing to the DPS when the contribution of all the independent variables becomes 0. When the contribution of independent variables is 0, what may be the contribution of your internal source? That is called alpha. That internal source efficiency is going to say that is called 17.91. It is nothing but we say in our SAPM security analysis portfolio model while doing performance evaluation models, where we use it, one model is a Jensen's alpha. Jensen's alpha is going to measure the management's ability. Whichever firms are alpha is high, we say that firm's management ability is high. Nothing but internal efficiency is high. So that 17.91 it is contributing positively to the DPS when the contribution of all independent variables are 0. Now let us come to the first independent variable EPS, how it contributes. For 1 unit change in EPS, there is a positive change in DPS by 0.1008. This is what it is. This is a change in DPS. This is what I say. What I am saying here, now the change in DPS by 0.1008 due to 1 unit change in EPS. If the EPS is increased by 1 rupee, in the DPS it will be increased by 10 paise. 1 rupee in EPS and DPS is going to be increased by, dividend per share is going to be increased by 10 paise. Approximate I am saying there value. Similarly for a 1 unit change in quick ratio, if the quick ratio is changed from 5 to 6, 1 unit change, there is a negative change in DPS. The DPS is going to be decreased by almost half. 0.49 means 0.5. If the 1 unit increase in quick ratio, there is a decrease in half in the DPS. This is what, how this can be interpreted by your coefficients. Like that all will be same. What may be the change in DPS due to change in 1 unit of EPS, 1 unit of QR, 1 unit of DE, 1 unit of CTR, 1 unit of size. Again here we have given some stars. 3 stars is more significant variable. First star is, we say that, listen to me, first star, wherever green color is there, that is a very, very significant variable in contribution to dependent variable. Again yellow color says that it is a very significant. Very, very significant, most excellent significant is green. Very significant is yellow. Pink is significant. Now here the 2 PPS and size are the most significant variables in contributing to DPS. QR and CTR are only very significant contributors to DPS. D is only significant. However, all 5 variables are significant in contribution, irrespective of their degree of contribution, irrespective of their degree, magnitude. But similarly, log transformation also we have used. With that equation, we got it. Now you see, but here intercept has become negative contribution. Intercept has become negative. It is not contributing internal source to the DPS. If it is a 99 minus it comes, there is a decline in 1. So there is a negative contribution. Internal efficiency is not showing anything. But when it comes to EPS, again there is a 1 unit change in EPS, there is a change in DPS by 2.65044. So it's very good. Like that, same calculation, there may be some positive, some may be negative. So in that, most significant independent variable for contributing to a dependent variable is green, is only one, that is called size. Now next is pink. Only size and pink color, first is size, next is EPS. Only two are significant variables in contributing to the dependent variable. Whereas quick ratio, DE and CTR are not significant variables in contributing to the DPS. Like that polynomial mathematical equation we have used, then with the result we got it from our software. This is what? 22.79. Again it is an intercept. It is a positively contributing when the contribution of your independent variables are 0. Now polynomial EPS is also contributing to the extent of 28.93 to dependent variable. So here size is also contributing to the extent of 0.000 for 1 unit change in size. Like that here EPS and size are the most significant variable in contribution to dependent variable. CTR is very significant, DE is significant. Again GAM model also we have used, like EPS is more contributing. This we have found it from your what we can call nominal deviance model, the figure result we looked at it, with which we have come to know that this is also more contributing. Now again non-linear least square model, that also says that contribution, here only two variables are more contributing, EPS and size we have taken. Out of this, now the question comes, which is the best among these 5? Which is the best model in predicting your DPS? That we have taken. This is what developing model. That is our objective, is to develop, to evaluate, to compare the models of linear and non-linear in business research. This is our objective. This is the first one, is what we are saying with respect to development of model. Second one we are coming, evaluation. When it comes to evaluation, which is the best model among the 5? We look at different parameters, different metrics in order to determine which is the best. Here I have taken, one is adjusted R square, nothing but what is the amount of total contribution of your independent variable to the dependent variable. What is the contribution? The total percentage of variance in dependent variable is explained by adjusted R square. Percentage of total variance in a dependent variable is explained by independent variables. Nothing but we have taken, again one more parameter is there, like we can also take like information criteria like AIC and BIC. That is also another parameter to determine whether your model is good fit or not. That despite having that data, we have not taken here for presentation. Like adjusted R square we have taken, again errors we have taken, standard error, like this is called accuracy errors. This is going to say precision of your prediction. Precision of your prediction. Lesser the RMSE, higher the prediction. Lesser the RMSE, the higher the contribution. The higher the R square, higher the contribution. P-value. If the P-value is less than 0.05, you say that the model is overall good fit. In these 3 measures, whichever R square is the highest, that is the best. In case of RMSE, whichever is the lowest, that is the best. In case of P-value, whichever has the least value, less than 0.05, that is the best. In case of all this model, now which is the best? GAM model is contributing to the extent of 97.94%, almost all 98% all independent variable together are contributing to the dependent variable of DPS. The 97.94% of the total variance of DPS is explained by those independent 5 variables. That is called EPS, again FIC ratio, again debt equity ratio, creditor turnover ratio and size. These are all 5 put together are contributing to the DPS to the extent of 98%. Hardly 2% is left out. It is a very good model. It is a best model. If any model is more than, in finance we say, more than 60 to 70, this is a good model, good fit model, R square. In case of marketing, 3 to 5, 30 to 50% in marketing is all rule of thumb. There is no any hard and fast rules. In social sciences like history and other sciences, less than 30% is good. 30% is also okay. But in finance we say up to 80, 70 is good. But it is a 90, it is just like in pure sciences we'll get. In physics, chemistry, in those sciences we get adjusted R square while calculating their non-linear model they get. So this is a very good model. Even RMS is the lowest in GAM model only, 1.309. Here 1.309 is the lowest. So among this, all the types of models, the least RMSE, that is called 1.309. Are you getting mine? Root mean square error that we can call. R means root mean square error. This is used for precision of prediction, accuracy error. Lesser the accuracy error, more the prediction, more the precision of for prediction. Lesser the accuracy error, more the precision for prediction. Next one is p-value. In all the cases, p-value is less than 0.05. Hence, these models are good fit. No doubt, all the models are good fit. In all the cases, adjusted R square are more than 90%. No doubt. All the models are very good. It is lucky enough that I have got this good result, I should say, proudly. Because we don't get this much good result in many of the data. Because this is the data, I took it, I got it. It is one of my research student is doing research on this topic. So we took the data and we have used. So here best performance is coming from the GAM model. So this model can be used for your estimation, for prediction of your DPS. Now this is what. Now next we have here certain diagnostic tests we use it. Diagnostic tests we use it. In order to validate our model, in order to confirm the best fit model, we use some residual analysis. Residual test we use it. That also we can call it a diagnostic test. After getting the results of regression, we use some diagnostic tests, which is also known as a residual test. These are used to validate our result, to know the genuinity of our result. To confirm our results are best, we should decide from our diagnostic tests, for which we use 3 tests, as you know, which I said in the beginning also. One is linear normality test, we use it. These tests are used, these diagnostic tests we are using from the residuals, not from the original data. We should calculate residuals for all the observations you have taken. How do you calculate residuals? I told you, actual observation minus expected, that we can call as a residuals. The residuals you have to get, from those residuals you have to calculate normality test, homoscedasticity test and autocorrelation test. Now Other tests I told you, linear, multicollinearity for determining whether which independent variable is considered for regression. Collinearity, that is called VF. Again, one more test I told you in the beginning, that is called linearity. Now some people, what they do, whether I want to go for linear model or non-linear model, for that you can initially test it to your data, whether your data is suitable for linear model or non-linear model. Using, I told you, Ramsey reset test or Harvey-Collier test. There are many are there. These are the tests we use it to decide whether this data is suitable for linearity or non-linearity. If the test is giving a hint for linearity, then we go for directly linearity. If the test is giving symptom for non-linearity, directly we go for non-linear, instead of wasting our time with the linear model. So here we test diagnostic tests, residual analysis test, we do it in order to decide whether my results are validated or not, for which we do 3 tests: normality test, homoscedasticity test and autocorrelation test. In all the 3 cases, we need null hypothesis to be accepted. In all the 3 cases, we need null hypothesis to be accepted in order to say my results are valid, my results are genuine. First we go with the normality test. Here we have done reset test, because I told you here, after doing all the different types of linear or non-linear model, now we are calculating reset test. Usually people will do it at the beginning itself, whether I want to go for linear or non-linear, because I am comparing the model, hence I have taken at the end. Why I should calculate in the initial itself to know it only linear are suitable, non-linear are suitable. Let me calculate at the end, so that after calculating all the types of models, linear and non-linear result, we'll see. Now reset. This is what first, this reset test is used to determine whether my model is, whether my data is suitable for linear or non-linear model. Here we set the hypothesis here. Now in the hypothesis, HY is, there is a linearity, HY is, there is a linearity. To get linearity, null hypothesis should be accepted, whose p-value should be more than 0.05. To get null hypothesis to be accepted, your p-value must be greater than 0.05. H1 is, there is no linearity, nothing but non-linearity. That is called alternative hypothesis. To get alternative hypothesis to be accepted, your p-value must be less than 0.05. 0.05. Now by testing this one, we from the reset test, our p-value is less than 0.05. It supports for non-linear model. Even in our calculation results also, our best good fit measures are non-linear model. So our test supports our results. Our test supports our result. P-value is less than 0.05, hence it supports non-linear model. So this is one we have done it. It should have been done in the beginning itself if you want. But I don't want to tell you there itself what is the best, what is not the best. So this is one we do it. This we usually do it at the beginning in the research. That is what we do it. Now other 3 tests we do it. That is what I told you. One is normality. Second one is homoscedasticity. That is, homoscedasticity is a null hypothesis. Alternative hypothesis is a heteroscedasticity. Third one is autocorrelation. First I am doing here normality test. This can be tested with the help of Shapiro-Wilk test. There are many tests are there, like Jarko-Bera is there, Anderson something is there, many are there. Depending upon the type of the data, how your data is there, how your data is, Based on that also we can decide which normality test we want to do it. If the robustness, if you want, we can go for Anderson, something is there. That test we use it in case of normality. But otherwise, we always go for like, if you adapt like E-waves adapts Jacob-Bera test. If you go for like Python and R, they adapt Shapiro test. Like that, each software adapts a particular category of test. But all, no doubt, almost same answer. Now here, when I do the Shapiro test, the p-value has come to 0.5949. This is what? The p-value is very important. In all the tests, when you do research, p-value is a must. With the p-value, it has become easier for the researcher to do his research. Earlier, we didn't get a p-value, we used to get one is a table value, another one is a calculated value. Table value is called it as critical value. Table value is called as critical value. Another one is a calculated value. Your calculated value is compared with the critical value. If your calculated value is more than critical value, we say that null alternative hypothesis is accepted. In case calculated value is more than critical value, we say that alternative hypothesis is accepted. If calculated value is less than your critical value, null hypothesis is accepted. For which we need to take the tables, the respective tables. The tables we should refer it under three situations. One is at single tile or two tile, one you have to see. Next one is significance level, you have to see at what level of significance you are testing, you have to see. Again, degree of freedom you have to see. All these three things should be simultaneously seen in order to know your critical value. That critical value must be compared with your calculated value. Then you can decide it whether your test is null hypothesis accepted or rejected. Such problem is not there now. The reason is that the p-value is readily available in almost all the softwares. Even the p-value is calculated using some Excel commands. Here p-value is 0.5949, so it is more than 0.05, so it accepts null hypothesis. Null hypothesis says that there is a normality. Your data is normally distributed. So this is one of the basic requirements for satisfying your data to be valid. Your results to be valid, excuse me, not data, your results, what you got, what you told, almost all your adjusted R square are more than 90, what you said. In order to say my results, those results are correct, very correct, this is very much required. Now this can also be visualized with the help of what we can call even histogram. This can be visualized, normality test, even normal QQ plot. Your all circles, original data is lying on your straight line. They are very closer to straight line, so that your data is normally distributed. So this is one test, we tested it as a diagnostic test. This is satisfied. Next we go to another test. That is what this test, this graph is used for your component residual plot for whether your data is linear or non-linear. But certain variables are linear, we find it like here it is there, it is a very much like straight line is there, it is a linear. This is not linear, but this is also almost linear. These two are almost linear. This also third is very closer to linear. When it comes, this one is not linear, but those are not coming because straight line is different. Your original is somewhere outside. Here is much more different. They are not together. So this is also diagram, we use it to decide it whether your diagram says whether linear or non-linear model. That is, what is the diagram name? Name of the diagram is component plus residual plots are used to determine whether your model is linear or non-linear. Then this is a visualization. This can be tested with the help of Ramsey reset test that has already been told. That I told you already. Now next one is another diagnostic test, we use it, that is called homoscedasticity or heteroscedasticity. We need our data to be homoscedasticity. We need our data to be homoscedasticity, for which null hypothesis has to be accepted. So to accept null hypothesis, our p-value must be more than 0.05. This is a common. To accept null hypothesis, your p-value must be greater than 0.05. To accept your alternative hypothesis, your p-value must be less than 0.05. Here your p-value has become more than 0.05, hence null hypothesis is accepted. So our data, our residuals are homoscedasticity. So this is another diagnostic test has been satisfied. So we have taken two tests for our this data. Third one more is their autocorrelation, for which either we can go for what we can call Durbin-Watson test, or we can also go for Bruish-Godfrey test. We can do it. That I have not done because only two tests have done it. With these two tests, we have satisfied our data to be a valid one. So this is what we have done. These are all calculations we have done. One more test people will do it in softwares is available, whether our data has some outliers, whether our data has any extreme values. That can be tested, that can be known with the help of Cook's distance. Cook's distance. Whether those extreme value has any influence on your other non-extreme values. That can be checked with this residual diagnostic. Only one or two are there as extremes, it will not have much impact on your other non-extreme values. If many are there, outliers or extreme values, then there is a possibility that having influence on the extreme values. So that extreme two are there. This is what bigger. These two are extreme values. These extreme values may not have much influence on other variables. So that is what it may not have. That also we can see, is there any influence or not of extreme values, that can also be checked. Now these are all we have done using our linear and non-linear model. Now we have developed the model with a mathematical equation. We also evaluated using good fit measures or metrics, using adjusted R square, using RMSE, using p-value. Another metric is also there, like that is what we can call it as a information criteria. AIC, Akaika information criteria, again BIC, Bayesian information criteria, we also use it, where we need the lowest value will be the best. Lowest AIC or BIC is the best model good fit. So that I have not, that is there in our data, it has come results, but I have not taken due to the non-availability of space in displaying our results. So these are all we got it from our this one. Now finally we can say that from our result, I told you already, but let me repeat once again. GAM model provided the highest adjusted R square and lowest RMSE, indicating the best predictive performance. It is followed by others are also there, like log transform model, linear log transform model is also there, non-linear least square model is also there, other models are also there. But the best model is GAM model, generalized additive model, where adjusted R square is the highest, RMSE is the lowest, and p-value is the least. So even we used residual tests, in which also it has satisfied to say our results are the best. Recommendation, we say that prefer GAM model for predictive purpose. Otherwise, use log transform model for simple interpretation if necessary. These are all my presentation which I have taken for this practical purpose. Hopefully, you have understood. In case any doubts, I will give my mobile number as well as my email number. Just contact me. I will try my best to provide the answers for the queries. Thank you. Thank you very much.